Warm greetings to everyone. I am Bhanushri B21247, and I, along with my other team members Anjani Sunda, Tanya Sheru, Shivani, and Vidula Anand, are here to present our data science project, that is taxi fare prediction. So the main aim of our project is that we wanted to concentrate on one of the day-to-day problem, that is when we travel, we tend to go to new cities, and there is always a chance that we get cheated by the drivers and all, because obviously we will not be having our own vehicle there. We would take any other public transport or the taxis. So in order to be independent there and have an idea of what charge we have to pay to the driver, so that we don't get cheated, we have trained a model, machine model, where we'll be taking some of the inputs from the user or the traveler, and we would try to predict the taxi fare of that particular city. So in order to do this thing, we have taken an example of a city, that is New York City, and taken the example of a New York City, and this is a real time data. We have used Kaggle to collect the data. So we felt some of the attributes which would be really useful for us to predict the charge, and we have taken four attributes, that is the pickup location, the drop location, the date, and the time during which the taxi or the traveler is using it, because these are the properties or the attributes which are really important to predict the data. And this is the data set which we have taken. So in order to be much more precise, we have taken the location of pickup and drop in terms of latitude and longitude. Then we have transformed the data into distances and then calculated and predicted it. So the phases through which the data is going to be trained and then the final prediction is to be done is that the first step is the data cleaning. Then we go to the second step, that is data transformation, where we transform the data and the time. Then after that, we train the model using some of the training examples. And then finally, we are ready to test the data and we try to minimize the error. So the model which we are using is that regression model, because the predicted value is a numerical value. So I would like my other team member to continue and explain briefly the next proceeding step.
Hi, I am Anjani Sunda B21278. Let's begin on how we proceed to predict taxi fare. First step is to do data cleaning. We remove the rows which contain null value and outliers of the attributes. We remove the outlier of the location with respect to the range of New York City. For the passenger count, we removed the attributes with more than 6 passengers. Second step is to split the data into training and testing data. Training set contains 70% of total data set and testing set contains 30% of total data set. With this, I would like to my next team member to continue.
I am Shirtania B21166. The next crucial part is data transformation. As in this part, we will convert some important attributes into numeric values so as to contribute in enhancing the performance of our training model. First, we split the date time attribute into two different attributes, namely date and time. In the uh, in the In this data transformation, we define few functions which will help in converting our attributes into numeric attributes. First, we converted the date attribute into days, namely Monday, Tuesday, and etc. Then we divided them into two separate phases, such as weekdays and weekends. Then, according to the demand for them on weekdays and weekends separately, we ranked them. Similarly, we splitted a day into four different time zones. Based on the demand at separate intervals, we ranked them into four different categories. For each pickup and drop off points, we calculated the distance between their respective latitudes and longitudes separately. Next comes the training phase. In this training phase, as the attribute we are going to predict is of numeric data type, we used a regression model. And in the regression model, we compared the RMSE values and proceeded with the next step. With this, I would like my next team member to continue with the presentation.
Hi everyone, I'm Shivani Dodda, B21188. And now, after knowing all these things like data cleaning, transformation, and all, now let us step into a crucial step which derives an expression based on the editings done on training phase. So now I want to explain about the expression deriving mechanism, and that is regression. And on seeing the term regression, we can derive that relationship or a link between the independent variables and also dependent variables. And this regression method is an easy and a friendly machine learning algorithm based on supervising learning. And now regression is mainly divided into two types, that is linear regression and polynomial regression. Those two can be further divided into sub branches. They are multiple and simple. Now, in the term multiple, we can know as we have many attributes which are independent, but output will be one, because we actually concentrate on one missing column, so that will be the dependent, and the other given variables will become independent variables. Now let us proceed to that the errors which we got based on this regression application. And now this linear regression, and the our ultimate goal of preparing an algorithm or deriving anything is to decrease error. Like how much precise we can derive, we have to try our best. And now we have tried first gone with the linear regression, and in this method actually we calculate the weights. If we have d attributes, that is independent attributes number is d, then we'll calculate d plus 1 weights accordingly to the correlation and all, and also how much it contributes to the output. And now we got RMSE error, like root mean square error value for multiple linear regression is 6.015. We thought this error is too much, so we have proceeded with polynomial regression. That polynomial regression is also known as polynomial curve fitting. With the heading itself, we can understand that polynomial represents the degree which is greater than 1. So curve represents the which is a degree of greater than 1. So here also we do the same thing, we calculate weights, but here something new we did is like raising the power of independent variables, that is p value. And here also we try to minimize our error. Here are the values of RMSE values for different p values. For p is equals to 2 is 5.177, p is equals to 3 is 4.9, p is equals to 4 is 4.698, p is equals to 5 is 4.602. Here we can observe the change between the error with p is equals to 4 and 5 is something around 0.096, which is very small. So it got saturated almost at p is equals to 5. So we stopped our model, like keeping time also in consideration to model and to train our data. So now I would like my next teammate to explain. And we also have some sample codes. Those are for polynomial regression. Here mainly we have to give the transformation and mapping of data. Here we can see the code, and this is how we train our model, our system. And this testing phase, we have to simply insert testing data into the trained model. Now it's over to you, Vidla.
Hi, I am Vidula Anand, B21172. Now let us have a look into testing phase. We did all the process on testing data which we did on training data. That is, we did data transformation on testing data by using the functions which we performed on training data. Then we used regression model on testing data. This is the regression code which we used for the testing data to predict the fair amount, and we found out the RMSE. The RMSE value of predicted value of test data was around 5.473. Not to stop with just modeling the data, we also made a simple user interface in Python to predict fair for a single input at a time. This is the code for the interface, and this is the sample output for our interface. I would also like to mention on how we can improve our model in future. We can add more attributes like weather conditions, whether it was sunny or rainy or windy or hazy day, and also amenities of taxi like whether it was AC or non-AC, and the fuel on which the taxi is running, and other amenities. To make the user interface more friendly, we can also make a web page at the starting stage for user interface and slowly build an app. With this, I and my team members would thank our professor and mentors for guiding us from scratch till the end of this project. Thank you.
Have a good